In this video, we're going to take a look at how to tell particles to have an increasing chance of something happening over time. Basically, their threshold is going to increase while the requirement decreases. And this is going to turn into a situation where the particles get activated and can do whatever else that we want them to do. In this case, we've got a bunch of particles berthed in a line out here, and when their chance turns on, or their chance reaches that threshold, then they're going to move forward in space. So just something pretty simple. Let's get another rule down here. We'll call this increasing chance. And what we're going to do is tell all particles, and this is kind of similar to our graph op ideas. Let's actually go ahead and grab that, and we will kind of reverse engineer it to what we want, because it has, we're going to take out those two. It has the value to time component that we want. We use value to time quite a bit in order to translate between two sets of values. So the value coming in here starts off with value 1 until value 2 corresponds linearly to a time output here, time being interpreted between 0 and 80. And you've seen this if you've seen the graph op video about what that does. What it does is it sends this time value out here into the fade in, and the fade in then has an animated curve on it, or actually not an animated curve, but a curve value, which goes from 0 up until time 80. It reaches a value of 1. Let's get that set up over here. And so what this does is this just kind of, as that particle's age goes from 0, in this case 1, let's go ahead and change that to 100. So as the particle ages from 0 to 100, this fade in value, of course, is going to be, it's going to rise from 0 at its birth, and it's got a little bit of a, Bezier curvature to it, so it's got fade in, fade out. But as that particle ages and reaches age of 100, it's going to reach this 80 time value, and it's going to output a value of 1. So you can directly actually go ahead and even set up a threshold here and say, okay, when we don't need that multiplier. When the fade in value coming in reaches a threshold of, say, 0.99, then we'll go ahead and activate whatever. In this case, we're going to go ahead and use a memory for each particle. It's going to know whether or not it's stored there, and what we'll do is we'll have it set a Boolean. We'll just call it I'm activated. Drag that down in here. Now let's turn this on, and so when that fade in value does reach that threshold, we will go ahead and see this memory turn on, and we're going to go ahead and set a Boolean value into here. Let's grab that. Boolean will be true, and then of course in our next rule we will use that true value. So all particles will check their memory, and if that output I'm activated Boolean is true, it's going to go ahead and feed into a velocity and just tell each one of those particles to have some velocity. Let's push them out in the y direction and no z. Put them at 100 speed. Okay, and remember that's 100 units per second, 100 world units per second. Okay, so what's going to happen here is, in this case, we didn't set up any randomization, so all of them have the same age. So as soon as they reach that 100 value and that threshold reaches, boom, they all take off at once. So what we're going to do is we're going to stir it up a little bit so that there's some randomization in there. Let's move this stuff around, give us a little more space. And so what we'll need is a random, of course. And we can also then just use an add multiply, take whatever this fade in value is, multiply it by a random, and use that as our threshold. And so this random, let's think about this. If we multiply it by 0, obviously it's going to be 0 and have a tough time reaching that threshold. Maybe we just want to reduce whatever this fade in value is by half. So we'll set the lower random value as 0.5, and maybe we will actually want to give it the potential of having a little bit more value than the fade in here, so we'll set our high value, number 2, to 1.5. Just set a random seed there. And we'll leave it at per call. And remember, per call means every time sample. Right now we're only set to per frame. But if you did, say, samples per second and did four samples per frame, which is 96 samples per second, that's going to mean this random is going to be generating a new value 96 times a second per particle, uniquely per particle. Okay, so let's go ahead and see what happens now as we scrub forward. Boom. Okay, so only a little bit of difference there. A lot of these are still based on that. Let's go ahead and increase our random possibility, and we will notice that, yeah, still kind of the same thing. That's not a whole lot. Let's increase the range. Okay, so even, normally it would be the particles would reach a value of like 0.9, somewhere around 90 or 100 frames old. But here we're multiplying by so much that they actually end up being activated even around 30. But we really would want a larger spread in between these. So let's take a look at how we can do that. One of the things we're going to throw in here now is a Timebase Helper. And the Timebase is going to allow us to modify time values per particle most easily with that variation right there. And what we can do then is we can actually take the value to time value that's being generated, pump that into this time, make sure we track it per particle, and then we can take that result, and actually let's disconnect this, or we just won't use that add multiply just yet. We'll connect that time into the fade in. So the fade in is now actually going to be subject to variations in the time interpretation. And then we can go ahead and take our value, put it in there, and let's see what we get. Okay, we get a lot more variation here. What's happened is the time base, the variation here, 78%. Remember, the way that variation works in TP is usually by setting a maximum, and that maximum right now is 100%, and the variation can be anywhere from that maximum down to 78% of the maximum. So basically down to what, 22? So 100 to 22 it can interpret from. But what we're seeing is these things take a lot more time than we really want in order to activate. So we're going to go ahead and we'll increase our time factor. Let's just go ahead and do 200%. So remember, this is actually going to up to double whatever time value is coming out. So we're getting quite a bit more change and variation in the timing there. Now, if we wanted to even further randomize it, which may or may not be necessary at this point, we could just plug in this random. This 5 is probably going to be way too high. But let's go ahead and see. Yeah, see, it takes right off. Now we can kind of recreate the same thing. Let's disconnect that, or actually let's leave it connected but use this fade in directly into the threshold again. And if we want to, we can either decrease this variation, or we can actually increase the total amount of time and then also increase that variation. So it really just depends. It's going to depend on what kind of timing we want. If we want them to all take off around closer to the same time, we're going to have a lower variation in the time base. Okay, so that's kind of one method of doing increasing chance over time. Let's go ahead and save that out. I believe this is the medium level. And let's just borrow that prefix name there. This is, we'll call this increasing chance over time version 1. And this will all get named to correspond with the rest of the file names. Okay, so that's kind of one method. Let's go ahead and take a look at another way of doing it. And actually, we'll break the video here to go do that.